Okay, let's talk about matrices. Now, systems of equations are something that we've known about. For example, I could give you this system of equations. And usually before, when we talked about a system of equations, we usually only dealt with two variables, x or y. With matrices, we can deal with more than two variables. When you were solving system of equations before, you were dealing with addition method, substitution method, or graphing method. Now we can take a system of equations and solve it by matrix. A matrix is simply just a rectangular array of elements. You have rows and columns. Rows go horizontally, columns go up and down. Matrices is the plural of matrix. The numbers in the rows and columns are called elements. For example, this is an element, it's 2. This is an element, it's 8. And again, numbers can aid us by eliminating the need to write the variables. For example, this system of equations, what you want to do is you want to know just the numbers, okay, just the coefficients. For example, in the first row, what we see is we see a 2, a 4, a 6, and a 22. So in our matrix, the first row would be a 2, a 4, a 6, and a 22. The next equation with the numbers we see are a 3, an 8, a 5, and a 27, which means the next row in my matrix would be a 3, an 8, a 5, and a 27. The last row in our equations, I have a -1, be careful, a -1, a 1, a 2, and a 2. So I have a -1, a 1, a 2, and a 2. Even though we don't write the ones here, they're understood. Okay, this is called an augmented matrix. Now, an augmented matrix has two pieces to it. We have this piece, the 2, 4, 6, 3, 8, 5, -1, 1, 2. These were the numbers that were actually with the variables. So we call this the coefficient matrix, the coefficient on the variables. This portion of the matrix here are equal. These are the answers, 22, 27, and 2. This is the answer portion of the augmented matrix. Dimensions of a matrix are rows by columns, okay? Rows by columns. And a matrix containing the same numbers of rows and columns is called a square matrix. For example, this has 1, 2, 3 rows and 1, 2, 3 columns. Therefore, this is a 3 by 3. Rows and columns match, so it's a square. Over here we have 1, 2, 3 rows and 1, 2, 3 columns. Therefore, this is a 3 by 3 matrix. The rows and columns match, therefore it is a square matrix. Now, again, this is a reiteration of how I would take a system of equations. First of all, the first column, let that so be your x column. So the values in front of my x's go here. Let the second column be your so-called y column. Let the values, the coefficients on the y's go there. And then you have this equal bar here if you'd like. Sometimes matrices don't have that, but that's okay. Just remember that the last column is always your answer column, and that's what you'll put in there. For here, this example, we want to write the augmented matrix of the given system of equations. I have one variable, two variable, and answers. That means that I'm going to have 1, 2, 3 columns, my x, my y, and my answer. I have 2 equations, therefore I'm going to have 2 rows. In my first row, I'm going to have a 3, a 4, and a 7. In my second, I'll have a 4, a -2, and a 5. Now, keep in mind that this answer is perfectly fine. You could also have that equal bar here for matrices. You do not have to, though. The order or dimension of this matrix, there are 2 rows. Remember, it's rows by columns. I have 2 rows by 3 columns. Row transformations. To solve a system of equations for matrices, we can use row transformations to come up with new matrices that have the same solution. We use row transformations to obtain an augmented matrix whose numbers to the left of the vertical bar are the same as the multiplicative identity matrix. Said another way, we can basically clear the matrix to be ones in the diagonals, zeros below. These asterisks here mean that they are any number. They could be any value number here, okay? Now, when you have ones in the diagonal and zeros below, this is called row echelon form, or REF. Okay? REF is nice and lovely. However, reduced row echelon form is even better. Reduced row echelon form is even better, and here's why. Because in addition to having your ones on the diagonal and your zeros below, you also have zeros above. Okay, and again, this is called reduced row echelon form, or RREF. RREF is lovely. Why? Because remember, your first column is your X, your next is your so-called Y. Maybe you have another one, let's call it Z. And your last column is answer. Which means, let me flip this over so we can understand this a little bit more, okay? So let's talk about this a little bit more. Now, again, this is your so-called X, this is your Y, let's say that's your Z, and your last one's always your answer. Now, for this row, what does it mean? I have 1 X plus 0 Y plus 0 Z equals some number. What does this row mean? I have 0 X plus 1 Y plus 0 Z equals some answer. Lastly, 0x plus 0y plus 1z equals some answer. 0 times anything goes away. So basically the first row here is saying x equals some number. Okay? The second row, again, the zeros go away, which is saying y equals some number. And again, the zeros go away for the last one, so you're really saying z is equal to some number. Well, isn't that lovely? Because to solve a system of equations is to come up with the intersection point of your lines. An intersection point is, what is the x? What is the y? What is the z, right? So this is completely solved for you. So RREF, reduced row echelon form, completely solves the system for you. Well, that's lovely, okay? Absolutely lovely. Okay, so let's talk about this. How would I do this? A couple of things with matrices is that you want to change the first, now we do this row-wise, okay? To do this by hand, we do this row-wise. Step 1, work with the first row. Change this element to a 1. Then step 2, get a 0. Step 3, get a 0. Next, go to the second row, get a 1 here. Next step, get a 0, get a 0. Next, go to the third row. I'm sorry, column. I keep saying rows. I'm sorry. We work column-wise. Go to the next column, get a 1 here. Next step, 0, 0. So these are the steps that you have to do. Now, sometimes it's advantageous to write the matrix in reduced row echelon form because you might go around and around in circles if you're doing it by hand. Well, we're going to show you how to do this in the calculator as well as by hand. Now, to do this in the calculator, we're going to use your matrix menu. Names is where you pick up your matrix. Math is where you do stuff to your matrix, and edit is where you put your matrix in. Edit looks like this. Edit, for example, will say, would you like to edit A, B, C, D, and these are the names in the matrices. So let's say I want to edit A. Let's say my matrix is a 2 by 3. well then I would put in my numbers. To get out of the matrix menu, you hit second mode, which is quit. Let's look a little bit more. You know what? Let's see. We had an example here. Let's put this matrix in. Here's my calculator. Turn it on. Okay. Now, there's my matrix. So I have to hit second x to the negative 1. I want to go to edit. Now, if you don't have matrices here, don't worry about that. I'm just going to write over them because once I'm done with it, I don't need it anymore. I'm going to have one highlighted and I'm going to hit enter. The matrix I want to put in is a 2 by 3. So I'm going to hit 2, enter, 3, enter. You see how it immediately changed the shape of that matrix? I'm going to just type in the numbers I need. 3, enter, 4, enter, 7, enter, 4, enter, negative 2, enter, and 5, enter. Be careful when you're hitting that negative 2, you hit the negative symbol. Do not hit the subtract symbol. Second, quit will get you out of the menu. That's how you put in a matrix. Okay, put a matrix into your calculator. Now let's talk about, well, what if I want to reduce row echelon, solve my matrix? All right. So let's go back into matrix. Second, x to the negative 1 gets me there. I want to go to math. That's where I do stuff to my matrix. I want to solve it. So let's go down until we see R, R, E, F. Be careful, they're right beside each other. So I want to pick this one, R, R, E, F, reduced row echelon form. I'm going to hit enter. I'm going to go back into matrix because now I've got to pick up the matrix I just made. Well, I pick up matrices under names. The one I just made was this 2 by 3 here. So I'm going to hit enter when A is highlighted. So now I have RREF of A. I'm going to hit enter, and notice that it's giving me decimal values. Let's say that I want to see fractional values. So hit math, fraction, hit enter, and enter one more time, and notice it spit out your answer as fractions, which means that this matrix here, that the matrix we had, let me write it down again. The matrix we had was 3, 4, 4, negative 2, 7, 5. It was a 2 by 3. We reduced row echelon to solve it. We got 1, 0, 0, 1, 17 elevenths, and 13 22nds. Now, what does this mean? First of all, I know I'm in reduced row echelon form because I got 1s on the diagonals, 0s above, 0s below. Remember, this last column is your answers. This is your column X. This is your column Y. This is your column answer. So really, what is this first row telling me? 1X plus no Y is 17 elevenths. Otherwise, saying that X is 17 elevenths. The second row is 0x plus 1y is 13 22nds. That means that y is 13 22nds. So there, it's solved my system for me. It's telling me that the intersection of these two lines is at 17 elevenths and 13 22nds.